Hello, it's Justice here. Welcome back to my channel. Today we're going to be solving Leetcode 121, best time to buy and sell stock. Okay, so let's read the problem statement and take a crack at this. So you're given an array of prices where prices I is the price of a given stock on that day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And then you also want to return the maximum profit you can achieve from this transaction. If you could not achieve any profit, we're going to return 0 if we can't achieve any profit. Okay, so we're going to look at this example 1. So we're going to say we have a prices array, and it's going to say, okay, we start at 7, so the price of the stock is 7. It goes down to 1, goes back up to 5, goes down to 3, goes back up to 6, and then goes down to 4. And we want to find which day we can buy and which day we can sell in order to have a maximum profit. Okay, so looking at this, we can see that if we bought on day 2 where the price was 1 and sell on day 5 where the price is 6, we're going to reach the maximum profit that we can get in the solution, which would be 5, in which you output into that's what you're going to return. Quick note on this, you cannot buy on day 2 and sell on day 1. So let's say if we were to buy on day 2 where the price is 1, we cannot sell on a previous day, so we can only sell in the future. So all the subsequent values after this day 2 we can sell from, but we cannot sell on a day that's prior to that. So I wish we could do that in real life, but that's kind of not how that works. So if you were to buy on a given day, you can only sell on subsequent days and so on. So given that, let's say if we were to buy on day 2 and sell on day 3, we would have a profit of 4. Buy on day 4, it would be a profit of 2. Buy on day 5, it's a profit of 5, and buy on day 6, and it's a profit of 3. And the maximum profit that we found when we were looking through that is 5. Okay, and let's go on to this second example. Okay, so for this second example here, we have a prices array that is always decreasing. So if you notice it, in this case, the price of the stock always gets cheaper, or always gets lower. So we start on day 7, it goes down to 6, then it goes down to 4, then 3, then 1. So if you think of it, we can actually never achieve a profit of a positive value because it's always decreasing. So let's say any given day we buy. So if we choose to buy it on day 1, let's say we buy it at day 1 when it's 6. The next day it's 4, so we're going to be losing money. Next day it's 3, so we're going to be losing money. Next day it's 1, so we're going to be losing money. And that holds true for every other case here too. So even if we're to buy at the day 1, all the stock keeps dropping every single day after, so we're going to be losing money. So in that case, if you cannot achieve any profit, so you cannot achieve a positive value when you buy on one day and sell on another, we're going to just return 0. And in this case, that's what they did. So you just return 0 because no transactions can be made to where we would get a profit. So the max profit would just equal 0. Okay, so we're going to go into this approach and how we can actually walk through a specific prices array so that we can find a solution that's most optimal. Okay, so hopefully this visual can actually visualize things a lot better for us so that we can kind of understand why these specific days in the prices array were shown to buy and sell. So first we start off with $7 on day 1. It's going to be $7 and it drops down to $1. So then it goes up to 5 and then goes down to 3, up to 6, and then down to 4. So if we were to buy it on day 7, every subsequent day after that, you'll be losing money because we'll be buying it at its high and then selling it at a value point that is going to be lower than that 7. If we were to buy it on day 2 here, where it's lowest, it would actually be best to buy it on this day because every subsequent day after that, the price, we can actually make a profit because if you see, the price is always going to be higher. This is the lowest kind of cheapest price that we can buy it at. So with that, every subsequent day after, we make a profit. So you can see here and here from day 2 to 3, we made a decent profit. We made a profit of $4. And then from day 2 to 4, we actually made a profit of $2. But then on day 5, this is where we made the most profit that we can make. Because if you see, that's the difference between the sell point on day 5 and day 2 is actually $5. And that's the maximum that we can do. Because even after this day, on day 6, it's going to be $4. So 4 minus that $1, we're only going to make $3 profit. So you can see that the best possible day to buy is at this low point of the cheapest price on day 2, and then the best possible day to sell to get the maximum profit from its subsequent days after that buy point is going to be on day 5. Okay, so as we go through, how are we going to do this? So as we go through this algorithm, we're going to make sure to look at what is the cheapest price that we currently can buy the stock at. So what's the cheapest current price that we can buy, and then based off of that, we want to see what is the maximum amount of profit that we can extrapolate from that cheapest value. So as we've seen in our example, we've seen the cheapest possible price that we can buy it at was at that $1 mark, and then we just kind of went through all the subsequent values in the prices array and seen, okay, what's the maximum amount of profit that we can get? Even if we can get a good profit, we need to find the maximum profit, and in order to get the maximum amount of money that we can get off a sell. So we found that to be day 5. So we're going to start off on day 1 as shown, and we're going to say, okay, what is the cheapest price as of right now? So the cheapest price as of right now is actually going to be $7 because we just started on day 1. We haven't went through any other stock prices from the prices array. So we're just going to say, okay, the cheapest price right now is 1. And remember, we can't buy and sell on the same day, so we can't make any money yet. So we're just going to continue our algorithm. Okay, so now we're on day 1, and we're going to say, oh, we found a new cheapest price. So the cheapest price is not 7 anymore. The cheapest price is actually 1. And we're going to say, okay, so what's the maximum amount of profit that we can get? But remember, we went from day 1 to day 2, so we went from 7 to 1. So it would not be wise to buy on or to sell because we'd be losing money because the price of the stock actually went down. So we're going to keep looping through this prices array. So we're going to go to day 3, and then we're going to say, okay, what is the cheapest possible price that we found? It's still 1 because the price actually went up to $5. So the cheapest 5 is actually greater than 1. So the cheapest price is still 1, but we're going to compute the profit. How do we get the profit? The profit is the amount of money we're going to get if we sell today. So how do we do that? We do that by taking 5. So if we were to sell it at a price of $5, we're going to say 5 minus the day that we bought, which was the cheapest price day. So 5 minus that 1 is going to be 4. So right now, the best profit that we can find is going to be 4. Perfect. And remember, we're trying to find the maximum profit. Okay, so now we're going to say, okay, now we're on day 4. We know what is the cheapest price. The cheapest price is still 1. So with the cheapest price still being 1, we're going to say, what if we were to actually sell on day 4? So if we were to sell on day 4, it would be $3. So it would be, say, $3 minus the cheapest price that we've seen. So if we sold today, it would be 3 minus 1. We would get a profit of $2. But that's actually smaller than the best profit. Remember, we want to get the best possible profit we can get. So 3 minus 1 is 2. It's still lower than 4. So right now, it still stands that the best day to buy is on the cheapest price day, and the best day to sell right now to get the maximum profit would be on day 3. So we're going to keep going. And then we're going to say, okay, now we've seen that the price is actually $6 on day 5. So we're saying, okay, what is the cheapest price? 6 is still greater than 1, so the cheapest price still stands at $1. And we're going to say, okay, what if we were to sell today? So if we were to sell today, we would make a profit of $6 minus the $1 that we bought it at. So 6 minus 1 is 5. Is 5 greater than the best current profit that we've already seen, or that we previously seen? Yes, because 5 is greater than 4. So we're going to update the best profit to be 5. Cool. And then last but not least, we're going to go to the last day, which is day 6, and we're going to ask ourselves, what is the cheapest price that we've seen? The cheapest price still stands at $1 because 4 is a greater price than the $1 value that we've seen. And we're going to say, okay, what if we were to sell today? We're going to still ask ourselves the same question. So if we were to sell today on day 6, we would actually get a profit of $3 because it's going to be 4 minus the cheapest price value, which is 1. So 4 minus 1 is going to equal 3. And we're going to say, is 3 greater than our current best profit? Is that the best we can do? No, because we already found 5, and 5 is greater than 3. So we're going to keep moving on. Now we've looped through all the numbers in our prices array. We've seen all the type of profits that we can get, and we found that our best profit that we're going to return is going to be 5. And that actually correlates with our diagram over here. So with this, if you've seen, we went through at most all the values in the prices array. So this is going to be O of n in time complexity, because at most we went through all the values in our prices array. And then space complexity here is going to be O of 1, because we did not initialize any other data structures. So this is actually the most optimal solution, and this is kind of what they're looking for in your interviews. So make sure you bring up this solution, and I hope the walkthrough made more sense and cleared a lot of things up for you. So now let's get into the code. Okay, so let's start with the coding implementation. So first we're going to keep track of the max profit as we go through the prices array, and we're going to initialize that to 0 because we said if we don't find a solution, we're going to return 0. So that's just an easy way for us to do that. We're also going to keep track of the minimum price, and right now we're going to initialize that to infinity because we want to make sure that the first value that we find in our prices array actually is our minimum price. And the way to ensure that is to create this value that's extremely large, so that value will be guaranteed to be lower than infinity, so that would be our min price to start. So price, we're going to go through the prices array. So price in prices, we're going to go through our prices array, and we're going to say, okay, what is the minimum price? The minimum price is going to be the minimum of whatever is smaller. So whatever is smaller of the current minimum price and the price that we're at. So we're going to continuously update the min price based off the prices that we see in our price array. So if we ever find a lower value, this min price will be updated. Second, we need to find the profit. And the profit for this, if we were to sell on this day, is going to be the current price that we're at minus the minimum price, or the cheapest price that we've seen within our prices array. And then we're going to update our profit, our max profit value. And this max profit value is going to be the max of the current max profit, or the profit that we've seen in this if we were to sell on any given day. So this is going to update. If this profit is larger, it's going to update the max profit value. At the end, we're going to just return our max profit, and we initialize that to 0. So if this never executes, if we never update, it's just going to return 0 cleanly for us. And then, yeah, that should be it for the algorithm. And it is very fast. So time and space complexity, we went through that, but go through that over again. So it's going to be O of n for time complexity, because we're going through at most all the values in our prices array to determine what is the max profit. So we're going through all the numbers in our prices array. And then space is going to be O of 1 because we're not actually initializing any other extra space or any data structures or anything like that. So yeah, I'll see you in the next video.